All right, this lesson is learning about distance and midpoint formulas. Real quick review of the Pythagorean theorem. If I have a right triangle noted by the 90-degree angle, we know that if side A and B are squared, it will equal our c squared, or our hypotenuse. So if I square the legs of the sides, I can find my squared value of my hypotenuse. All right, so knowing that, we are going to be able to find the distance using a formula of a line. So this blue line noted right here, if we gave you the points of the endpoint and the coordinate of the other endpoint, we can use a formula to find the distance of this line. Now, using the Pythagorean theorem, we also could find that because it's the hypotenuse of a right angle. So if I just had this blue line and I made a triangle, we could find what this side equals by taking this x value and subtracting this x value, and we would have a number. This line, if I took this y value, subtract it from this y value, I would have another number. We could then square the two numbers to get our c squared. That's kind of hard to understand. So I'm going to show you that same thing what I just said in a formula. All right, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's the formula. It's very long, but let's look at this graph one more time. Let's say this here is side A. x2 minus x1 squared. That's this x value minus this x value, which gives us the distance of this line. But we know to find c, we have to square that value. Then we need to add it to this side, b. The y2 minus the y1 will give us this length from here to here. So y2 minus y1 squared, because we have to square b, should give us c squared. But this distance, which is our c, we don't want to be squared, so to unsquare it, we have to do the square root of all of this. Okay, so giving us our final formula again, distance equals square root of the x's subtracted and the y's subtracted. Both of those are squared, added together, and then we find the square root of that final number. So let's do an example. What is the distance between 0.11 and 79? Now I don't even need to graph these. Using our distance formula, the more you write it, the better you remember. We can find the distance. All right, distance is square root. x2, I'm going to say this is my x1, y1, x2, y2. So x2 minus x1, 7 minus 1 squared plus 9 minus 1 squared. 7 minus 1 is 6. 6 squared is 36. 9 minus 1 is 8. 8 squared is 64. Distance equals, I want to add this up, 64 plus 36 is 100. Finally, the square root of 100 is 10. The distance from these 2 points is 10. Now, the midpoint of a line segment is the point M that is the same distance from this endpoint as this endpoint, meaning it's in the exact middle. So, basically, if they give you coordinates for the two endpoints, We can find this midpoint value with this formula. Notice they are adding the x's, dividing by 2, adding the y's, dividing by 2. Your answer, because it's a point on the graph, is going to be in coordinate form, some x and y. Let's do an example. So we have a line. These are the endpoints. I set up my formula. Midpoint equals x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So basically I'm just going to add up the x's, 3 and negative 5, put that over 2, add up the y's, 6 and 1, put that over 2, do some simplifying. 3 plus a negative 5 is negative 2 over 2. 6 plus 1 is 7. 7 over 2. Negative 2 divided by 2 is negative 1. 7 divided by 2, we can either leave it as a fraction or we should always put in a mixed number. This is our midpoint of this line with those two endpoints. If this was 3, 6, and this was negative 5, 1, which doesn't really make sense, negative 1, 3.5 would be right in the center. Rewatch those examples if you feel the need. The examples I went through are on page 605 if you would like to read them in your book. I'd like you to complete the exercises 1 through 6 found on the bottom of page 605. Oops.